What's up, y'all? It's Mr. Canada. In this video, we're going to introduce ourselves to functions, the definition of a function, and looking into examples of functions and non-functions. So if you're joining me for the Algebra 1 series, this is the first video of the series. Hope you guys enjoy. So, before we talk about functions, it's important that we know what the building blocks of a function is. And that building block is what we call a relation. So what is a relation to begin with? Basically, a relation is a relationship between two sets of value or data. Now, in order to better understand that, let's make an example. Now, what's two sets of data that we can compare to? Well, to be fair, you can pretty much compare anything you want. You can compare age to height, you can compare age to money, you can compare whether you have a degree and maybe, again, comparing it to salary. You can pretty much compare anything you want. But for this video, what I want to compare is this. I want to compare the drinks that I like, and I want to compare that to the set of data that is going to be my mood. So what are some of the drinks that I like to consume? So one of the things I like to drink is I like to drink coffee. I don't know about you guys, but I need coffee to start off the day every day. So it's not addiction, trust me. So another thing that I like to drink is soda. Now more specifically, I really like to drink Coke. I can't tell you how many different types of Coke that I've had. And let's go ahead and put something healthy in there. I also like to drink a nice hot tea. Now, if you're looking for recommendations, I prefer a really nice black tea or a green tea. Really soothes the mind. So, let's go ahead and compare the drinks that I like to have to the mood. So, what do I mean by mood? Well, what I want to put here is I want to compare it more specifically to how I feel after I drink those coffee, hot tea, or soda. So for example, I'm going to compare it to being awake, and I'm also going to compare it to being sleepy. Now, let's think about this. These drinks are basically my inputs. This is what I am consuming. This is what I'm putting into my body whenever I want to have a drink. What my mood is going to be my output. It's the after effect after I drink the coffee, the soda, or the hot tea. Now, what we want to try to do is that we want to establish comparisons. So, what are some comparisons that we can establish here? Well, I know for sure, at least for me, and it could be different for other people, whenever I drink coffee, I tend to be awake. Because all the caffeine, all that sugar, all that creamer, you name it, is pumping through my veins. It's keeping me awake, especially if I've had a long night. Now, is that the only thing that actually makes that mood happen? Not really. If I drink soda, at least for me, it also makes me feel awake. So both of these items, when I drink it, makes me feel awake. But what happens when I happen to drink hot tea? Well, at least for me, when I drink hot tea, it makes me feel sleepy. So notice what I'm doing. I'm comparing my inputs to one of the outputs, which in this case is my mood. Now, I want you to think about this. Can it be possible for every single one of these to have a double effect? Well, in this case, it really can't. If I drink coffee, I can't both simultaneously be awake and sleepy because, at least for me, coffee really only makes me feel awake. The same thing can be said about soda, at least in my case. Whenever I drink soda, I tend to be awake and I'm not really sleepy. So that's going to be my next point here. Every single one of these has exactly one effect that's tied to them. And that's exactly what a function is. A function is basically where every input in the first group of data goes to exactly one output or one effect in the second group of data. Now, more specifically, we can expand that and talk about different types of graphs, tables, and equations. So let's actually look at a good working definition of a function. So a function is an equation for which any x that can be plugged into the equation will yield exactly one y out of that equation. Now, does it always have to be an equation? Absolutely not. It can also be tables. It can also be graphs. You're basically looking for inputs and outputs. Any input that can be plugged into the equation will yield exactly one output out of that equation. In other words, every x has exactly one distinct y value. And that's a very important definition, especially in our study of functions. Now, let's look into some examples of functions that apply this definition perfectly, because it's a good idea to see what kind of different flavors of functions there are. So let's go ahead and see what a function is. So in our first example, we have here what we call a mapping. It looks similar to what we did before with our relation example. Basically, in a mapping, the first group is always going to be x, and the second group is always going to be y. Or you can also think of it as this is going to be your input. Oops, I can't spell it today. And this is going to be your output. So what should we look for? Basically, if you're asking yourself, is this mapping a function? You basically have to ask yourself, is every x going to exactly one y? In this case, this 1 has an arrow pointing to the a, this 2 has an arrow pointing to c, and this 3 has an arrow pointing to b. Every single one of these x's goes to exactly one y on the other side. So, does that fit the definition? Absolutely. So this is going to be an example of a function. Now, here's a pretty confusing example. Look at this table. Remember that this right here is your inputs, because it's your x's, and this is your outputs, because it's your y's. Now, we have to check to see if every x value goes to exactly one y value. In this case, the number 1 goes to an output of a, this input of 2 goes to an output of b, this 3 goes to a c, and this 4 goes to an a. Hey, wait a minute. There's a repetition of a's here, so what gives? Basically, this is what you have to think of. It's okay if your outputs repeat, because technically speaking, this x value, this of 1, only goes to this a. This 4 only goes to a. It would be a problem if, let's say, we had, instead of a 4 down here, let's say we had a 1. And this was a different output. Let's just say this was a, let's just say it was the letter D. This would be a problem because this x is going to an a, and this same exact x is going to a different value. It's okay if the y values repeat. It's a bad thing if the x values repeat. So in this case, what we have to keep in mind is just ask yourself, does every x go to exactly one y? In this case, it does. It's okay if the y's repeat. So this is going to be a function. Okay, what about the next example? So this is what we call a line graph. Basically, in order to determine if this is going to be a function, we have a really nifty test, and it's called the vertical line test. Now, this is a really nifty tool to use whenever you're asking yourself if a graph is a function or not a function. Basically, this is what it says. The vertical line test says that if I drop a straight line down going through the graph and it crosses only one point, then it's going to be a function. Now, let's be a little bit more specific. It doesn't matter where I draw this vertical line, because notice that I'm always hitting one point on that purple line per line. So if I draw it over here, I only touch it once. Even if I draw it over here, it only touches once on that purple line. So no matter where I draw my vertical line, I'm always touching the purple line just once. So this is going to be an example of a function. Okay, well what if it touches more than once? Well, in that case, if it touches more than once, the vertical line test has a second conclusion. If it touches 2 or more times, then that graph is not a function. We're going to see examples like that in just a second. So here's another example. We have a couple of dots out in space, coordinate points. So this is a very specific type of graph. This is what we call a discrete graph. We're going to talk about that a little bit more later on. So this one, all you have to do is apply the vertical line test again. If I draw a line there, it only touches this point, so we're A-okay. If I draw a line here, I only touch one point again. If I draw a line here, I only touch once again. And if I draw a line here, again, I only touch once. So no matter where I drew that blue line, I only touched one point. So this is going to be a function. Okay, let's go ahead and keep going. In this example, we have coordinate points. Not on a graph, but just written out. Again, one thing you have to remind yourself is that this is a coordinate point. These are x and y's. So all you have to check is, does every x go to exactly 1y? Well, in this case, this 1 only goes to 2, this 3 only goes to 4, and this 5 only goes to 6. So that checks out. So this is going to be an example of a function. Okay, what about this last one? This 1 goes to an a, this input of 2 goes to that same a, and this input of 3 also goes to that same a. So is this going to be a function? This is the one that confuses people a lot, because they think, oh, all of those inputs are going to the same number. It must not be a function. But remember what the definition says. Every single one of these x's goes to only one value in the output y. And in this case, that's true. This 1 just goes to a. It doesn't go to any other number or any other output. This 2 goes to a2 and doesn't go to anything else. And this 3 only goes to a. Again, it doesn't go to any other y value. So this checks out. This is going to be a function. So in this first part, we've noticed all the different types of examples that make up a function, and they all share one thing. Every single x had exactly one distinct y value. And in some cases, it's okay if all of the x values went to the same output, because they all went to one single thing and not two different things. So is every equation, table, and graph a function? Absolutely not. Let's look into examples of what makes a relation or a graph, table, equation not a function. Let's look at this first example. In this example, we have 1 going to a, 2 going to b, but we're noticing that this 3 isn't going anywhere. Now in this case, this violates the definition in this way. Every x has exactly one y. And if one of these x's doesn't go to anything, then that means that this is not going to be a function, because this x doesn't have a y. Let's look at this next example. Here we have a table, x and y, couple of numbers here, couple of letters here. This 1 goes to a, this 2 goes to b, this 3 goes to c, and this 1 goes to d. I mentioned this one before. Notice that there's a repetition of x's here. This violates the definition because this input of 1 has two different y values, two different outputs. The definition says that every x has exactly one y, but this x has two y's. So this is going to be an example of not a function because they have two different y values. Let's look at the next example here. Here we have a graph, basically points again. Let's see if we can figure out whether this is going to be a function or not. Well, if I draw a line here, it only touches once. If I draw a line here, it only touches once. And if I draw a line here, notice that this blue line touches 2 points. So remember what that means. If the vertical line touches 2 points or more, then it is not a function, regardless if every other line only crossed once. We got 2 more examples. In this one, we have a nice circle graph, nice shape of a circle. Okay, if I draw my vertical line, you're going to notice that the vertical line touches 2 times on that circle. So what does that mean? Basically, that means that the vertical line tells you that it is not a function. I hope you guys are getting the picture about what makes a function and what doesn't make a function. So, one more example. So again, this is a mapping. This 1 goes to A. This 2, you might notice it has 2 arrows. This 2 is going to B, and this 2 is also going to C. That should be signaling off red flags that, oh my gosh, this X value, this input, has 2 different outputs. That means that this is not going to be a function because that X does not have exactly one Y. It has 2 different Ys. So what's the big idea? The big idea is that a function is basically an equation, table, or graph where every X has exactly one Y. We saw into examples of what made a function, and we saw examples of what made it not a function. Well, I hope you guys learned something new today. If you liked the video, give the video a like and subscribe to my channel for more Algebra 1 videos. If you have any questions, you can leave them in the comments below, and I'll try to answer as soon as I can. But y'all go ahead and take care, and I'll see you guys next time.